Hi guys, welcome back to my channel. I am Meghna from Preventeshwara College of Engineering. Today I am going to explain about the topic under the subject of DBMS, which is handled by Arpitama. Today our topic is desirable properties of transactions, characterizing schedule based on recovery. Desirable properties of transactions. Transactions in a database our system should exhibit four key features, often refers to the acronym ACID, atomicity, consistency, isolation, and durability. These properties ensure that database transactions are reliability, accurate, and secure. Atomicity. Definition of atomicity. Atomicity ensures that all operations within a transaction are completely successful or none of them are completed. This property prevents transaction from being left in an inconsistent state or case of failure. Illustration. An image representing the concept of atomicity such as unbroken chain can visually convey the idea of invisibility and completeness in the context of database transactions. Consistency definition. Consistency ensures that the database remains in a valid state before and after the execution of the transaction. It prohibits any transaction from being the database to an inconsistent state. Important database consistency is crucial for data integrity and accuracy. Without consistency, the databases may produce incorrect results or violate integrity constraints. Guarantees. Consistency guarantees that all constraints are satisfied and that the data remains in the valid state throughout the entire transaction before process. Isolation. Data integrity ensures that the current execution of the transaction results in the system that would be often if transactions were executed serially, maintaining data integrity. Concurrency control. It provides a mechanism for the controlling and managing concurrent access to ensure that a transaction do not interfere with each other during execution. Preventing anomalies. Isolation prevents phenomena such as dirty reads, non-repeatable reads, and phantom reads, ensuring a high level of transaction integrity. Durability. Definition of durability. Durability guarantees that once a transaction is committed, its changes remains in the system and they are not lost even in the event of system failure. Recoverability. It involves maintaining a permanent record of committed transactions, allowing system to recover them from failure without compromising the integrity of the data. Redo logs. The use of redo logs is a common technique for ensuring durability by recording the changes made by the committed transactions. Characterizing schedule based on recoverability. Firstly, schedule recoverability. Recoverability checks if the schedule is capable of recovering from failures, restoring the database to a consistent state after encountering an error. Recoverable schedules. These schedules allows for the recovery of the database to a consistent state by undoing the transactions that caused the failure and restoring the actions of transactions that were made before the failure. Cascade-less schedules. These schedules prevent cascading rollback by ensuring that if the transaction reaches the value, it must be from the transaction that has already committed. Recoverable schedules. Strong recoverability. It guarantees that the database returns to a state that could have maintained happened if the transaction are executed serially. Cascading rollback. If T2 reaches the value that is written by T1 and T1 is rolled back, then T2 reads is invalid. Preventing this is an aspect of recoverable schedules. Conflict serialization. Recoverable schedules ensure conflict seriability, a property thus ensure the outcome of concurrent execution is equivalent to some serial execution of some transaction. Cascadeless schedules. Transaction T1, transaction T2, and relation between the two. Lastly, we can have the summary of these topics. Desirable properties of transactions and characteristics of schedules based on recoverability in database management system include atomicity, consistency, isolation, durability, recoverability, transaction logs, checkpointing, seriability, two-phase commit, rollback, and roll forward. Atomicity means transactions should treat as an invisible unit, ensuring either all operations are executed or none. Consistency means transactions should bring the database from one consistent state to another without violating constraints. Isolation means transactions should be isolated from each other during execution to prevent interface. Durability means committed transactions effects should persist even in the system failures. Recoverability. Systems should use transaction logs to ensure that in a phase of failures, the database can restore to a consistent state. Transaction log. Detailed logs of transaction actions and changes aids in the recovery by undoing the incomplete transactions or redoing the committed ones. Checkpointing. Periodic checkpoints involve writing modified buffers to disk and recording in a log, reducing recovery time. Seriability. Schedules should produce the same result as if the transaction were executed sequentially, ensuring a consistent final database state. Two-phase commit. All nodes in distributed transactions must agree to commit or abort, ensuring global consistency. Rollback and roll forward means systems should allow rollback, undoing changes from the committed transactions, and rolling forward means changes from committed transactions during recovery. Adherent to these principles ensure data reliability, consistency, and recoverability in database systems. Thank you.